Now we are required to prove the compound angle for cos into theta plus alpha to show that cos into theta plus alpha is equivalent to cos theta cos alpha minus sin theta sin alpha, utilizing the compound angle formula for cos into theta minus alpha. So one thing that we know is that cos into theta minus alpha is same as cos theta cos alpha plus, if in between the angles it's negative, then this will be plus sin alpha sin theta. So this will be sin theta. So now let's check from here. We check our left hand side. Our left hand side, it's same as cos into theta plus alpha. So we try to expand, we'll have cos into theta, but then in the middle I want to have something similar to a compound angle of cos. So we are going to have cos into theta minus into negative alpha. Then in expanding this, we are going to have cos theta. We expand using the compound angle for cos. This is cos theta cos into negative alpha. Then the angle in between is negative, so it will just be plus sin theta sin into negative alpha. That's according to the expansion, this expansion here. So thereafter we are going to have cos theta, and then cos of a negative angle, it's positive cos that particular angle, which is alpha, and then minus sine of a negative angle, it's negative sine that particular angle. In our case, we are going to have negative sine theta, then sine alpha. That's it. We have proved that particular identity. So now let's move on to the next problem. We are required to prove that sine into alpha minus theta, sine into theta minus alpha, it's equivalent to sine theta cos theta minus sine theta cos alpha. So let's check. Let's look at our left hand side. Our left hand side is equivalent to sine into theta minus alpha. So in order for us to expand this, we are going to utilize co-functions or co-ratios. We know that sine into 90 degrees minus theta is same as cos theta, and we also know that cos into 90 degrees minus theta is same as sine theta. So we are going to apply this notion here. So in applying this notion, we are going to say, we'll simply say, we are going to introduce cos. We'll just say cos into 90 degrees minus that angle that we have, which is theta minus alpha. This is the angle in question. So subsequent to this, we can also rewrite this as cos into 90 degrees minus theta. Then we try to distribute this negative, we'll end up with plus alpha. Then when we try to expand, this will just be cos into, we expand using the compound angle for cos. This will just be cos 90 degrees minus theta. This is the first angle, this one. This is the first angle, then this is the second angle. So we are going to have cos 90 degrees minus theta multiplied by cos of alpha. We expand using the compound angle for cos. Then we'll have minus sine, the angle in question will have 90 degrees minus theta multiplied by multiplied by sine, this is sine alpha. Let's try to erase it in order to write it properly. This will be sine alpha. Thereafter, what is cos into 90 degrees minus theta? This will change to its co-ratio, which will be sine theta multiplied by cos alpha minus sine 90 degrees minus an angle will simplify to sine according to the co-ratios up there. This is sine theta multiplied by sine alpha. So this is a trigonometric identity. It's a trigonometric identity. So we have proved that the left hand side is equal to the right hand side in our case. Now let's move on to the next page. Then in the next page we are required to prove that sine into theta plus alpha is equivalent to sine alpha cos theta plus cos alpha sine theta. So in proving this, let's just pick the left hand side in our case. We pick the left hand side, we quickly pick the left hand side. We are going to have a left hand side, it's equal to sine into theta plus alpha. Thereafter, we are going to write this as sine into theta. Instead of writing plus, we are going to write negative into negative alpha. When you simplify that which we have in the middle, it will still simplify to positive alpha. So we expand this using that which we have up there. Already we know the expansion when we have a negative in the middle. So this will result to, we are just going to say this is sine, this will just be sine theta multiplied by cos into negative alpha, but because it's negative and we are dealing with sine, it will still be negative. You subtract cos theta multiplied by sine into negative alpha. This is how it's done. Thereafter, we are going to remain with sine theta multiplied by cos of a negative angle. This is positive cos alpha, then minus cos theta sine of a negative angle. This will be negative sine alpha. Thereafter, this will further simplify to sine theta cos theta plus, because negative multiplied by negative is positive, cos theta sine alpha. Here I made a mistake, it was supposed to be alpha. Then that's it. We can safely say that the left hand side is equal to the right hand side. Now let's move on to the next page. Now we are required to prove that sine 2 beta is equal to 2 sine beta cos beta. So with this one, what we simply have to do, just to pick the left hand side is similar to, it's sine 2 beta, but 2 beta can be written as, we can just say this is sine into beta plus beta, which can further be simplified using the compound of sine. We know that sine into theta plus beta is same as sine theta cos beta minus, sorry, this is plus cos theta sine beta. So we are going to expand using that notion. So moving forward, we are going to write this thing as sine beta multiplied by cos beta plus cos beta multiplied by sine beta. So if you check, we have like terms here. We have like terms. We can safely say, this is 2 sine beta cos beta. Remember, for us to get to where we are, let's just say left hand side it's equal to the right hand side. For us to get to where we are, to say our angle will be beta and beta, we just say let theta to be equivalent to beta, so that your work becomes easy. Where you see theta, you replace it with beta, then that's it. Now let's head to the next question. We have cos 2b is equal to, either it's cos squared beta minus sine squared beta, or 1 minus 2 sine squared beta, or 2 cos squared beta minus 1. So let's start. The first one, in proving the first problem, in dealing with the first problem, this is how we do it. You just say, from that which we know, from cos into alpha plus beta, it's equal to cos beta cos alpha minus sine beta, sine alpha. You simply let alpha to be equal to beta. That basically means that you'll just have cos into beta plus beta. It's equivalent to, remember we have already chosen our, this is the same as cos 2 beta. So our left hand side, we are saying it's cos into beta plus beta. So we are going to expand this. When you expand, this will be cos beta multiplied by cos beta minus sine squared, this is sine beta, sine beta multiplied by sine beta. When you simplify, this will just be cos squared beta minus cos squared beta. We have proved the first one. Then let's move to the second one. wherein we want to prove that cos 2 beta is similar to 1 minus 2 sine squared beta. So from that which we have there, we can simply write this thing as, we can say from that which we have, we know that this side we have we have cos squared beta minus sine squared beta as the left hand side. This is the left hand side. So we want to show that the left hand side is equal to this. So we are going to say from the square identity, we know that sine squared theta plus cos squared theta it's equal to 1. This is equal to 1. And we also know that sine squared theta is equal to 1 minus cos squared theta, and also cos squared theta is equal to 1 minus sine squared theta. So we can further eliminate this. Where we see cos squared theta, we can change this cos squared beta into 1 minus sine squared beta minus sine squared beta. This is the left hand side, remember? So we are going to remain with 1 minus 2 sine squared beta. So we have proved the second one. Now let's head to the third one. In terms of the third one, we are saying 2 cos squared beta minus 1 is equivalent to cos 2 beta. So from what we have proved up there, we know that the left hand side is equivalent to, not the left hand side in our case, in our case we'll just say the right hand side, we'll say the right hand side is equivalent to cos 2b. This is the right hand side. Then, and this thing, we managed to show that cos 2b is same as cos squared beta minus sine squared beta. So now we are going to change this one. So in changing that one, we can safely say cos squared beta minus into, where we see sine squared beta, we write 1 minus cos squared beta. Thereafter, we will have cos squared beta, we distribute the negative, minus 1 plus cos squared beta. Ultimately, we'll just have 2 cos squared beta minus 1. Therefore, left hand side is equal to the right hand side. Even here, left hand side is equal to the right hand side. Even this side, left hand side, it's equal to the right hand side. Both sides are equal. They are equal to each other. So there are some problems when you are dealing with trigonometry. They will want you to utilize half angles. Remember, we were talking of the double angles up there. Now we are dealing with half angles. But these half angles, we are going to take them from the double angle identities that we were dealing with just now. So you will just say from that which we have up there in the previous frame, we are just say from cos 2 beta being told that it's equal to 2 cos, this has to be 2 cos squared beta minus 1. Whatever we do, we are doing it from this point. We are using this as a point of reference. So now, in our case, we can safely say, let's halve the angles. Let's just halve the angles. This cos 2b will now become cos b. If we halve the angles, we'll have cos b on the left hand side. Then in the right hand side, let's say we halve the angle. We are going to have 2 cos squared. If we halve the angle, we'll no longer have beta, but we'll have beta divided by 2 minus 1 in this particular fashion. So now the main intention is to have cos beta divided by 2. So to get to that, we will first have to transpose this negative 1 to the other side. We'll have cos beta plus 1. It's equivalent to 2 cos squared beta divided by 2 in this particular fashion. Thereafter, we try to divide both sides by 2. You divide both sides by 2. Thereafter, you are going to have 1 plus cos beta divided by 2 is equal to, remember these two will divide each other, we remain with cos squared of beta divided by 2. But what I want is cos beta divided by 2, not cos squared beta divided by 2. So what do? I'm just going to introduce a square root both sides. So we are going to say cos squared beta divided by 2 it's equal to 1 plus cos beta divided by 2. Then I'm just going to root both sides in order to eliminate the exponent 2 that I'm having here. Then I will remain with cos into beta divided by 2, which is the same as plus or minus the square root of 1 plus cos b divided by 2. That's how it's done.